Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Automotive Ethernet Moving to Time-Sensitive Environments, brought to you by Synopsys, Tech Online, and broadcast by UBM. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, you can participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window, and then click the Submit button. At this time, we recommend you disable your computer's pop-up blockers. This will allow the slides to advance automatically throughout the event. You may also download a copy of the slides by clicking on the Additional Resources button located below the presentation window. Also, if you're experiencing any technical problems, please visit our webinar help guide by clicking on the Help link below the presentation window. In addition, you can contact our technical support helpline, which is also located in the webinar help guide. And now, on to the presentation. Automotive Ethernet, moving to time-sensitive environments. Discussing today's topic is John Swanson. John has been working in the IP business since 1990 when he joined Logic Automation, or Logic Modeling, which was later acquired by Synopsys. John has worked in the design, verification, integration, and implementation aspects of complex IP in engineering methodology and business development and marketing. He has been working on system-on-a-chip technologies and methodologies for over 10 years with Synopsys in a variety of assignments. Currently, he is the product line manager for the DesignWare Ethernet family of digital cores, as well as JPEG 1394 and the IP reuse tools. Welcome, John. I'll now hand it over to you to begin today's presentation. John?
All right. Thank you very much. And I also want to thank everybody for attending this webinar. We've put together a good selection of slides to kind of cover what is not necessarily a new topic, but an area which has certainly been getting a lot of interest in the last few years, especially as we're getting more and more computers in the cars. So what we're going to do is I'm going to go through sort of a background or overview introduction on what's going on in automotive and why we're seeing the need for time-sensitive networking and Ethernet in particular. We'll go through some of the key specifications that are part of the different IEEE working groups, as well as some of the new technologies that are not necessarily in your car today, but are being planned for 5 years down the road, 10 years down the road. We need to keep in mind the automotive life cycle is much different than the consumer electronics life cycle. We'll talk about the IP requirements and then briefly kind of highlight the Synopsys solutions for automotive electronics. So to begin with the overview, I've been with Synopsys a long time, and I've had many exciting assignments. And several years ago, I was tasked with getting more involved in automotive and what's going on there. And it's really an exciting time because we have a complete redesign of everything in the car. I mean, it starts from the drive system. So we're shifting from a pure hydromechanical to electromechanical. Now, lots of times when I say that, people make the leap that, oh, you're talking about electric cars. Well, no, not necessarily. You might have technology like the drive-by-wire that BMW has been promoting. So there's many things going in the cars that are shifting to electrical mechanical. More and more software and dependencies on the different systems, right? I mean, years ago, we had little contained systems that ran redundancy, that would maybe control the brakes. What we're getting today is all these systems are starting to communicate together, and there's more and more of them on the cars that are being designed today. With all this going on, we've got to maintain the safety and reliability, and ISO 26262 is sort of the benchmark for this. There's lots of different parts of it. We'll go into some of them today, and that's an area where we can certainly, provide more detail than we'll be, able to in the time we have today. Another key thing is the design chain collaboration. With more and more, aftermarket products and, kind of a consumerization of what's going on in the car, it's really important that things designed by one company can work with another company, and you have the ability to bring these systems together in a car without compromising the security. And all of this, you have new applications. Collision avoidance, which is mandated going forward in some countries. Certainly trucks in Europe are being required to have collision avoidance systems. Automatic parking. Boy, I would love to have automatic parking. It can get you in those teeny little parking spots that you maybe drive by because you just aren't confident enough. In-vehicle infotainment or entertainment and advanced driver assistance systems. These have begun as sort of two separate things, but they're kind of combining together as we look at the designs that are being done today. And of course, the power and electrical systems in the car. So everything in the car, from the engine through all of the electronics, is being re-engineered, and it's really an exciting time in the automotive industry, and kind of a nervous time, which we'll elaborate on a little bit more. Now, one of the things I can tell you, we're seeing a lot of companies getting very interested in automotive. With all of these new projects, you have companies with different core technologies. It might be their sensors, it might be their GPU technology, all working to get in to the automotive market and somehow. And a reason why is because it is forecast as one of the fastest growing markets. We've had over 10% CAGR forecast from 13 to 18. There are a lot of designs going on in automotive, and this is the kind of chart that all the business and marketing people want to see. It's up and to the right, more designs, right? I always like to take a step back because when you look at the electronics in a car, and we tend to kind of go into the infotainment descriptions of these advanced systems, but there is a lot of electronics in a car that is not part of these. For example, there's a lot of analog, there's a lot of power electronics, lots of memory and growing amounts of memory in the cars. So there's a lot of different components that make this up, but with all the new applications and the push to make the car more of a consumer experience, IVI, ADAS are clearly driving a lot of the designs that we're seeing today. So to focus a little bit more on Ethernet, this is a survey done by Gartner the end of last year, and what it was polling people on what communication technologies will they be using in the future. Now you'll note that unlike consumer electronics, when we talk about anticipated in automotive, we're looking pretty far out. And no surprise, CAN FD is still the dominant one, with most designers looking at it for their next projects. And this is not a surprise. All of the safety critical systems, existing designs that already used CAN that are being taken forward. So it is no surprise that CAN is still number one. But some people were surprised at how big of a number two Ethernet was. So you had 40% of the people that responded said they're looking at Ethernet now, and another 40% are looking at it for their next project. So it's being designed in today, and people are looking at it in the future. Some of the other connectivity technologies, LIN and FlexRay, I'm not going to say they're going away, but they're certainly not as dominant as they used to be. And then you start getting into the question of how many networks do I need running on my car? If I can consolidate it, I can maybe simplify the software. Now, Wi-Fi showed up on this survey, which was a bit of a surprise, and I would not expect to see Wi-Fi kind of running things in the car, but it is becoming a way to connect the car to the rest of the world. And as we start bringing the automobiles into the metropolitan infrastructures and things like that, again, the need for time-sensitive networking is important. So why are people looking at Ethernet? I mean, there must be, some reason. People don't, switch in automotive without, good, solid reasons. And in the same survey, what we learned was that, it's the long-term usefulness of the ability to address these communication needs. With more computers, more data, more sensors, we have a lot of information being transmitted throughout the automobile. Lowering costs. If we can use a standard like Ethernet in a car, then we can definitely work on getting the cost of developing these systems, lower. And this is one of the factors which would, kind of make me wonder, we may not need Ethernet to adjust the position of our seat, but if that's just one, point on an Ethernet network, maybe it will be easier. Ability to address the data-centric services that people want. And what I mean by this, it's everything from your online music to maybe your the automotive company wanting to collect information, do updates, and things like that. So more and more, data-centric applications. Time to market, something which never used to show up in automotive unless you were talking about horsepower, is on every automotive company's radar right now. And it's not just getting the new car out, it's getting the new car out with the features that people want. Reducing the wiring complexity. If you look at the amount of cabling and wiring in cars, it's just scary. So if we can reduce it and simplify it, that makes the wiring simpler, but also can potentially reduce the weight, which helps with gas mileage, which is, of course, being mandated. Software diagnostics, improved vehicle data communication. An example of that might be multiple cameras looking at the back and side needing to be synchronized to give the driver, a clear picture of what's going on behind him. And we can, using Ethernet and TSN or audio video, we can bring multiple streams together and merge them and give the user a better experience. And then improved customer experiences and product differentiation, kind of rounded it up at the bottom. So given all those things, it's no surprise that there's a huge growth in Ethernet ports forecast. And if we look at this, again, no surprise, entertainment is number one. There's a fair number of people that are doing projects which are deploying now and in the short term, and many people are looking at them for down the road. Onboard diagnostic systems. These were the first Ethernet ports in cars, and BMW has been very vocal about how important Ethernet is. You open up the hood of a BMW for a software update, and there's an Ethernet port that the dealer will actually hook their computer to do software updates and get diagnostics on your systems. Driver information and warning. As I said, these are merging with infotainment and clearly going to be growing. Vehicle cameras, driver assistance, different sensors. So you can see many, many different applications are going to be using Ethernet. And it might not be pure Ethernet. So if we think of like the camera, so I'm not implying that you're going to have an Ethernet cable running to the rear camera. More likely, this is going to be a cabling system such as the new SenseWire, which is being defined by MIPI, or sometimes known as I-Cube-C, which will connect the camera to the Ethernet network, which is providing the data to the consumer. So lots of ports, lots of different applications, and lots of ports. And the other thing to notice here is you'll see in around 2019, we start seeing Gigabit. Today, automobiles are 10-100, but there's a need to drive them to Gigabit, and we're heading in that direction. So it's about the automotive living room. We're in our car, we want our context, we're going to be interfacing with the real world through these data systems, and it all needs to be a good, safe consumer experience. So let's look at some of the specifications. There's a lot going on in the IEEE. In addition to ABB or TSN, there's the 1588, there's a reduced twisted pair Gigabit Ethernet study group, and there's all the various 802.1, 802.3 specifications. There's a standards group called Avenue, which is focusing originally on AVB interoperability, but really moving more into a TSN. And I'm going to elaborate on the differences in those going forward. The Open Alliance, which helped get the UTP-1 single twisted pair for Ethernet and automotive deployed. You have ISO. There's the VCIC and numerous standard certifications. And then you have a group called Jasper, which is focusing on high-speed vehicle networking going forward. Now, when we look at AVB traditionally, and this is being used in chips that are in cars today, there's sort of three parts or two parts here. There's the AVB specifications, which are part of the 802.1 working group, and there's 1588-2008, which is actually outside of the 802.1, but to implement 802.1 AS in your Ethernet network, you require a hardware implementation, according to the specification, of 1588. So it's a combination of hardware and software that have made up the audio-video bridging standards that have been out there. And if you apply this to a typical design, you have your master, you have different bridges and endpoints that are all connected together. So for example, this might be 2 rear cameras, 2 side cameras, a couple of switches, and the information is being displayed to the user. And we're able to keep track of the time and the delays through all the cables and all the different media components that make up the AVB network. This is out. This is working, not only in consumer, but in automotive applications as well. Infotainment drove a lot. Driver information drove a lot. And these two systems are merging. I mean, it's not uncommon today to go, look at the new cars, and instead of having, multiple displays, having one HD quality display that all of the information is available on. So driver information is changing a lot. We look at some of the other standards, right? We've had the 10100 PHY, and we're looking at, we need Gigabit. And so there's a lot of activity going on, and there are sample chips available that are supporting Gigabit on automotive standards. 1588, it's been pretty quiet in 1588 land for a while, but there's a lot going on right now. So sometimes people get confused on 1588. So it's been around a long time. There's 1588-2002, which is often referred to as 1588 V1. And there's 1588-2008, which is the version 2 of it. Now there is a PAR for an update, which is tentatively named 2.1, where we're targeting 2017 as the completion. And some of the work being done here is promoting the layered architecture, adding precision accuracy, and we're talking incredibly high precision down that's used at like the White Rabbit project at CERN. Probably won't be having that kind of precision in a car anytime soon, but the protocol, the networking ability to manage the time will be there. Redundancy, security, and management. And some of these, there's a great deal of debate going on about how they will be implemented. But there will be changes down the road. High accuracy appears to be an option that will not be required going forward. But as you can see by the target release dates, we're fairly far out for that coming. The one I want to focus on a little bit more is sometimes what's known as next generation AVB, which we all are agreeing we should call TSN. So AVB was audio-video bridging. It was originally created to address high-end audio-video applications, but as people started looking at it, there were a lot of other applications that it could fit. So there are a lot of different working groups going on in the 802.1 right now. We have draft specs for several of them. We're focusing on low latency, guaranteed bandwidth in a bridged LAN environment. Now, as we're making these updates to the spec, there are going to be changes to the MAC layers to support real-time applications. And there'll be potentially some changes to some of the traffic shaping algorithms as well. Now, what's driving a lot of this is, AVB addressed a lot, but when you look at automotive and industrial, or what was kind of tagged at the TSN conference as the Internet of important things, things that need to understand time and things like that, these specifications are needed, and really the working group is moving forward, really to make sure what we put out is good and solid and will work. So to be clear, AVB is audio-video bridging. It started in 2005, took several years to get the specs together. The Avenue Alliance was created to support this, and it was really, targeting the audio-video. Now, I think it's a safe assumption that this was not as successful as many people had hoped. If you look in the consumer space, many companies have proprietary audio-video solutions. And, when you look at the business, right, standards are great, but if there wasn't a standard and I created something of my own and I am the market leader, why would I want to adopt a standard? So there is some of this going on, but AVB was a good step. Now it's TSN. And although I'm using AVB a lot in today's webinar, going forward, you'll quit hearing AVB and you'll start hearing all of these specifications referred to as time-sensitive networking. And there's a lot of different requirements being driven from automotive, industrial, government movements like Industry 4.0 in Europe are really helping to grow time-sensitive networking. And everybody involved in it really wants to make this happen. So there's a lot of different groups that are involved in it. I just wanted to quickly highlight some of them. So there's the update to the AS specification. There's the QBZ. This update is going to involve significant changes in the MAC and scheduling. The specs are getting fairly solid, fairly mature, and so it's kind of at the point now where you're doing the architectures, you're looking at how the RTL will need to be updated going forward. You're also looking at updates to QBV and different standards as well. Now, some of these are newer, and what you'll see is we've recently approved a PAR, and we're starting the task group ballots, and that would be true for the CB and the other ones as well. So lots going on under the TSN umbrella, and we at Synopsys are making sure that the IP we provide will be supporting these new specifications as they get solid and come out. So we have a glitch. Okay. Now, one thing which I think really shows how much interest there is in the TSN is earlier this year there was the first conference on TSN, and I think they were anticipating maybe 70 people showing up. It was down near Great America. So many people showed up that on day one they were frantically running around the hotel to get chairs. Late registration was huge, and on-site registration was huge. And we had people from all over. We had people from automotive. We had people from industrial. We had people from the standards groups and from the high-end networking. And I think the big takeaways from this are don't call it AVB anymore. Call it TSN. People are still trying to figure out what it means on Ethernet, and it will be deployed going forward. The momentum is there. So lots going on. It's a huge success. The papers that were presented at this conference were very high quality, and they were showing a couple different things. A, how people look at the TSN specifications for the future, and B, how people have got around the limitations of timing in 802.1 networks with proprietary protocols, and a concern that the TSN specifications could make changes required to quote several presenters, gazillions of proprietary protocols. Well, the good news is the way TSN is being set up, the different protocols will be able to work with it. So very successful conference. So TSN in the future will be enabling a lot. I mean, a network is really just a bunch of nodes and wires, and the wires might be, wireless wires, so it might be communicating through LTE. But there's lots of different things running on it, which is not so simple. But actually, for timing, it can be. And the way that gets put together is you have your different higher layer applications which talk to the media-dependent machines that make up a network. Each one of these can run self-contained, but with a common clocking and common timing will be able to communicate not only within the automobile, but also outside of the automobile to the municipal. Maybe I'm giving position information for traffic control. Maybe I need to clear highways for emergency vehicles and things like that. So at the higher applications, the cars start communicating with other things in the network. And then to take a step back, as I said, Ethernet has been in cars for a long time. Introduced in diagnostics, Synopsys was involved in some of these chips. Around 2009, with the early AVB specifications, you had the infotainment and advanced driver assistance systems coming out. These were using the audio-video bridging, energy-efficient Ethernet came in, and different ISO specifications as well as 1588. Going forward, there'll be updates which will enable the TSN specifications. So in addition to the IEEE updates, there's people looking at time-triggered Ethernet. There will be updates to 1588, which I've covered. My opinion is that there will definitely be partial networking in probably the next several generations of cars. I don't see Ethernet in the critical system soon, but I do see Ethernet as kind of the main network that the other systems communicate to get information to the driver. There could be other things too. There's a lot of people working on it, and if there's new standards that come out that make sense, they could be adopted as well. And sometimes we come up with things in the IEEE working groups and stuff that need a new classification. I think the other big thing is you will see Gigabit Ethernet in the short term, and that's actually kind of important. Lots of times people ask, why do we need Gigabit Ethernet in a car? HD video. We're already having to compress the video that we're transmitting. You may not really need HD video in a backup camera, but remember, we're also trying to get a consumer experience. Consumers want HD quality. So in addition to knowing there's something behind them, they want a very clear picture and real-time motion. So all of these things are driving Gigabit. And what's coming down the road? So if we look at the emerging technologies, right? So most people have heard of the Google car. If you travel to Silicon Valley, you may have seen the Google car on Highway 101 in traffic, for example. So you have the semi-autonomous or autonomous vehicles, and at the automotive shows and at the consumer electronics shows as well, you're seeing companies start to show their concept vehicles for a complete self-driving car. Mercedes had one where the inside is kind of set up around a coffee table, so people can sit and talk, and the car just drives itself. It's a trend. Will we ever get to fully autonomous? Maybe. Certainly there's things that could be brought in. I think more in the short term as we start getting into the the kind of infrastructure. You have vehicle-to-vehicle communication and vehicle-to-infrastructure communication. When an emergency vehicle is coming to a traffic signal, being able to notify the other cars about it. When a train is coming and going to do a crosswalk. When you have vehicles potentially, turning into each other, having information, at this level can help make the driving experience safer and can help the different, municipalities have a more robust infrastructure. This gets handled through cloud connectivity. And now that we've left the car, security is going to be key. There's already stories starting to come out about, security in cars, and they're not the kind of things you think of. I mean, personally, I'm not too worried about somebody taking over the computers in my cars when I'm driving down the road. Security gets to be, a little bit more interesting. So one of the, big trends in cars today is the keyless entry and keyless ignition. What a lot of people do when they come home is they throw their key on a table by the front door. The key is transmitting information about the car. There was a case here in the States not too long ago where kids had figured out how to pick up the information coming from the key fob and use it to open people's cars so they could break into the cars. And there was a whole neighborhood of cars that had been broken into. So there's an example of very simple security. Clearly, we need to secure anything in critical systems, and most of these systems are going to, stay isolated for a long time. We're targeting all different users, and here, you can certainly see generational differences. I'm older. When I was younger, cars were all about horsepower. We wanted bigger engines and go faster. Today, it seems like people are more interested in the features of the car. They want the electronics, they want the infotainment kind of environment. They want to be able to hook their different toys up to it. And so all of these things are popping in as technology trends in the cars. And also, we're driving these outside of what I would call traditional, automotive processes. So we're seeing 28 nanometers today, and we're seeing companies investigating 16 nanometers. Now, with that said, there's still a lot of automotive chips that are using, larger processes. And I think one of the key things here is a lot of the infotainment and the IVI, this stuff is still outside of the critical systems. As they move into the critical systems, you start having to do the temperature certification and other types of certification. But we are definitely seeing a move to the smaller geometries. Now, one thing, when we talk about autonomous driving, can you imagine the Google car in pretty much any intersection in Bangalore, India? There's too many things going on. Also, many of the roundabouts, like one you may have seen in Paris, these are clearly situations where a fully, self-driving car is probably not, real likely. And I want to give credit, Stefan Redbering presented these two cases at the TSN Conference. So drivers do need to take over, even when you have autonomous driving. Now here you clearly know you need to take over, but sometimes you may not be aware that you need to take over. And here's one reason why timing is so important. If you're going down a highway at, say 65 miles an hour, and something happens, it is taking over 900 feet to stop. Now, there's also the human delay. So if your car is driving itself and you're not really paying attention, and something has happened which requires you to take over, in addition to the actual stopping distance, there is going to be the human takeover time as well. So these systems are very important. Most of them today are passive. We're providing driver's assistance. We're warning the driver something is happening. We're warning them in enough time for them to take action. But we're moving towards more of an autonomous system, which I'll elaborate on that. So with all these safety features coming in, ADAS, is the fastest growing application for the semiconductors in cars. We're seeing over $3 billion demand for these systems in the next 4 years. And it's going to grow, and governments are regulating it. And it's being deployed today. Now, I like to use this as an example because I actually bought my wife one of these cars, and it has this eyesight capability, and it is an incredible safety feature in the car. So from the outside of the car, you look at it, and it almost looks like, above the driver's mirror, there's a set of eyeglasses. And what it's doing is it's using an optical technology to avoid front-end collisions. Works very well, unless the sun is right in the front. So if we're building systems that need to be reliable, in any environment, and let's face it, cars get subjected to really brutal environments, we need to look at the larger system. So for front-end collision, we're going to have a combination of optical and radar, both. Because if the sun is directly in front of us, the optical is not working, we can't not have the collision avoidance, so there'll be a radar system as well. You'll have these things working together. During hard rain, the radar might be getting too much interference, so you need the optical to support it. So it's going to be a merger of systems. You're going to have surround view to avoid changing lanes and colliding with the cars next to you. You're going to have long-term, you're going to have parking, you're going to have all these different driver assistance systems that are all going to be working together. And this is a lot of data that is being deployed in the network. And I've mentioned several times, connecting to the cloud, the municipality. So this is not new. LTE is available in cars today. This was just one I picked where Volvo introduced a new cloud-based system. So if the cars are now connected to the cloud, now the different cities can start getting the information, maybe not only on traffic patterns, but on gas consumption and things like that. So lots of, when we have data, people find things to do with the data. The Internet of Things and the Internet about important things, of which the car is one of, data helps us make decisions to give people better experiences. And that lets a city have a complete digital overlay. You have the clouds. You have the different buildings connected to the cloud. We know the road. We know where the different the traffic lights are. If there's an emergency and we need to route things, all of this starts getting tied together in a digital infrastructure, and it can make life in the city better. So what are the requirements for this? Well, first of all, features. The IP clearly has to support the features you need. So for Ethernet, it's 802.3, 802.1 specifications primarily. You need to be able to bring this into your design. So what we've seen is companies with existing products adding Ethernet to it. So you may, for example, have an MCU, which has been successful in automotive, and you're wanting to expand that into in-vehicle infotainment or advanced driver assistance. So you need the IP to be able to easily fit in. Maybe you're using an AMBA interconnect. Maybe you're doing everything through a memory architecture. Documentation. I can't emphasize how important documentation is. When you're creating automotive systems, you have to do certification of the systems. When you're creating chips, you certify the chips. And as an IP provider, we're helping you create that documentation and giving you IP, which we've taken through a certification process as well. So I'm not going to go through all the features, but there's a lot of them that are important, and we've kind of highlighted some of the main ones. When you look at the top companies, we have been doing Ethernet business for a long time with these companies. Now, recently we did an announcement which kind of summarized some of the work we've been doing to make it easier for companies doing these chips. We have, in the IP group in Synopsys, we have very high quality. We track all issues, we report all issues. we wanted to kind of take that to the next level or see what we needed to change to go to the next level. Now, the good news was we were already pretty much where we needed to be, but we've also expanded it to actually provide safety packages. These include not just our internal process documentation, but reports that we provide to companies that license our IP to help them create their documentation. And this includes, reports and the verification we've done, and including the FMEDA assessments and things like that. So we've been investing a lot. We've been working with third parties to make sure we are here to supply IP. It's not just Ethernet. There's many different IP titles, and we have gone through the process to do the ASIL B Ready IP and making significant investments in our quality and quality management processes going forward. Quality management is, the manuals, the control, the records. It's basically documenting everything from conception through implementation and making that documentation available to companies that need to do their own documentation. We do numerous deliverables, and this is not new to automotive. This is something we've been doing for some time. We maintain all the different versions. We track all the issues with versions. And then there's numerous reports that we can provide you, including compliance, coverage, verification. All of this is centrally maintained and managed by our digital IP safety officer. So, to kind of wrap up, there's a lot of Synopsys IP. We have been doing Ethernet for a long time. We support 100 gig down through 10100. We have been the #1 Ethernet IP provider for multiple years. QoS is really the core that's kind of, focused on the automotive. So this is the one that has the existing AVB and will be updated for future TSN standards going forward. It's been used in multiple applications. We have right around 50 licensees for this particular core to date, many of them automotive, but also in switches and consumer applications. In addition to the RTL and the configurability kit of the RTL, you also get a robust software driver where we've implemented things such as multi-channel DMA, the AVB, the jumbo frames, and things like that, all included. Now, somebody might be thinking, your IP is really configurable, and you're, giving me this and expecting me to figure out how to configure it. Well, we've actually kind of, raised the bar there. So you get a configuration wizard with our IP, and you can quickly go through and try different configurations. The configuration wizard also will stop you from doing an illegal configuration. So, for example, if we're implementing, multiple audio-video channels in our design, we're required to have a hardware implementation of 1588. So, when you were configuring your IP, if you selected audio-video bridging through a certain number of channels, the 1588 RTL will automatically be included, and you can't disable it because it's required by the specification to be there. So you get a lot of guidance to help you get your configuration right, and you can quickly try different things. I already talked about this, but just to kind of reemphasize, we recently announced the safety package for the Ethernet QoS core. Since we'd already done a lot of automotive designs, this was the logical, one. It's like, let's do this one and see, how close we are to needing what we needed to be. And we're not only close, we're there. So this core, as I said, is already used in multiple automotive applications, and it is not only in infotainment and advanced driver assistance, but it is used in some safety critical systems. Now I want to be clear. I think sometimes when companies build these kind of chips, you have multiple CPUs and you have multiple connectivity ports. The Ethernet part may not be under the hood yet, but it is in the chip. And companies going forward are putting together these chips with multiple interfaces so they can get more designs, because you want to get the volumes up there in automotive, which is always a challenge. It's also, to help this, I'll go through these quickly. We announced IP Accelerated, which is not just the IP, but it's bringing our IP portfolio and some of our technology, the software development, the hardware kits, and bringing experts to help you do your own IP-based subsystems. Now, if we focus again on Ethernet QoS, and one thing which is actually quite cool for automotive is you can use this HAPS VF system. It comes with everything pre-built. It's an out-of-the-box startup environment. You can make changes to this design. So let's say, for example, I start with a base and I want to go to 8 audio-video channels, and the default was 2. And so I change a configuration, regenerate the RTL, all the tools you need, put it back on the board, and you can rerun different simulations and different tests. All of these come pre-instrumented so that as you make changes, you can run simulations using the HAPS DX Deep Trace Debug and see what is going on. But then what I see, which I think is most important for automotive, so we've talked to several companies which are what would be the traditional tier ones. So companies that are building the systems for the Toyotas, the BMWs, and things like that. And what we're seeing them want to do is do an FPGA prototype of this system, work with a company that's actually going to build the chip, take that FPGA prototype and bring it into a larger prototyping system. And so they're able, to make changes fairly late in their design flow, run with the real world, plugging, hardware into these systems, and work very closely with the OEM companies. So it's a win-win. You have the ability to bring your CPU, the different cores, and your custom logic all together in a very good environment. We also can provide hybrid prototyping kits. So these are going to be running a Linux kernel, a virtual prototype type environment where you can try different things when you don't have the hardware. So you can start working on the software development much sooner. All of this is part of a very broad, robust IP portfolio from Synopsys. So I've focused on Ethernet. We also have, the DDRs, things like MIPI. And as I said, I think SenseWire, I2C will definitely be seeing automotive interest for the sensors. HDMI. So I might say, HDMI, why would you put HDMI in a car? Well, you need that high-quality display. You may want people to be able to plug their own devices in. So there's lots of applications. USB, and it's not just for power charging, right? It might be for storing media and things like that. And PCI Express, which is often used for connecting modules together. We have a variety of different processors. We have, the ARC-HS, the ARC-EM. We have the new Vision processor and also ASIPs, different subsystems, and all the different logic and memories and data path technology that you need to build an automotive SoC. So that pretty much wraps up the slides I had. Any questions?
All right. Well, thank you, John, for a great presentation. And now, before we begin with today's Q&A, please fill out the feedback form that's opened up on your computer. To complete the form, please press the Submit Answer button at the bottom of the page. Thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. We're now going to move on to our question and answer section of the presentation. As a reminder, to participate in our Q&A session, just type your question into the text box located below the media player, and then click the Submit Question button. Please note that we'll try to get to as many questions as we can in the time that we have left, but if we don't get to your question today, someone will follow up with you directly after the webcast is over via email. So let's move on now with our first question. Our first question for you, John, why would you need a Gigabit Ethernet connection in a car? You have dedicated channels for critical data, and 100 meg would be sufficient.
Yeah, so I touched on that a little bit in the session, but I really didn't expand on it. It's really to eliminate the need to compress data. So video, even non-HD video in cars today is being compressed. So, if we think of a camera in the back of a car, so a backup camera, it's collecting the data, and then the electronics that is communicating that data to the display is having to compress it, transmit it through the wire, and uncompress it. So a lot of these, sort of bridge chips are including the CPU to do the compression or the hardware to do the compression. By going up to Gigabit, we eliminate the need to do the compression. It helps things run in more real time. And as we bring more and more HD in, we really have a need for Gigabit. So, to the consumer, you may not see that much. To keeping the cost of the electronics down, Gigabit will definitely help in that space.
All right, thank you, John. Our next question for you. Is IP also available for FPGA applications or SoC ASIC only?
So our focus is really on the ASIC. However, for Ethernet and the 10100 gig, we've had many customers use these in production FPGAs. So you can certainly use it on an FPGA. There's no issues there. And many companies do prototyping of these systems with FPGAs as well.
All right, John, our next question for you. You said that you have your IP certified, but is not certification required on the system?
That's actually a great question because certification in cars is multi-leveled. So part of what ISO 26262 dictates is quality throughout the entire supply chain. So we're supplying IP to semiconductor companies who are building chips that they have to certify to supply to the tier 2 companies, which certify the systems which go into the cars, and then of course the automakers have to certify the cars. So it's multi-tiered. So, as I said, we actually hired a consultant to go through it with us. And it was actually kind of fun because there was a lot of debate, in the engineering team. So, when you look at FMEDA, right, if something illegal happens and a bit in a register goes to an illegal value, what does that mean in the system? So, in the context of the IP, we can document that. In the context of the system, if you're reading that register when it has an invalid bit. So you have context that's IP related, context that's system related. They have to do the certification, and then they provide it on up the supply chain to the car company. Certification in critical systems is multi-tiered, and we at Synopsys have really stepped up to do the certification and provide the documentation for the IP that will help companies do their larger system. It's kind of a long-winded answer, but it's a really good question, and there was certainly a lot of debate on it.
All right, thank you, John. Our next one for you. Car networks contain MCUs that operate as a gateway. Does Synopsys IP support NAT protocol or offloading?
We certainly support offloading. In the QoS, there's numerous offload features related to the packet handling. So, depending on exactly what the application is, the answer is probably yes. But we do support it in the Ethernet IP.
All right, we're going to try and sneak one more in here. Is Ethernet entering the critical systems of cars? I ask because things like cameras and collision avoidance systems may be part of the car's in-vehicle infotainment system.
Another very good question. So this has, sort of been an area of debate. A critical system historically would be, for example, your anti-lock brakes. When I step on the brake, I expect the car to stop. Infotainment or providing driver information to help him make decisions has traditionally not been part of the critical systems. But as we get into more active driver assistance, it's certainly probable that these will become part of the critical system. So your backup, collision avoidance could certainly become part of it. So I think what you're going to see in Ethernet is an evolution. The first rounds of critical systems will be, in the ADAS sort of world. We won't be running Ethernet cables to the braking system in the short term. That's going to stay with what's already proven and certified for safety. But over time, we may see more and more of the Ethernet move into the traditional. So again, IVI is a subject of debate, or ADAS is a subject of debate. Probably will be classified as critical system, but we might even end up with multiple tiers of critical systems. Actually, if you look at the tables for certification, some of the questions are things like, if it fails, what does the failure mean? Will it cause a catastrophic accident? Will it be an inconvenience? I don't remember the exact categories, but there is a list of them, and they're very well defined. And ADAS will certainly be moving into some of it. So yes and no is the answer to that.
All right, I'm going to sneak one last one in here. So time-sensitive network Ethernet is not based on CSMA CD.
I'm not sure I completely understand that question, but what we're the time-based Ethernet is using the 1588 as defined by the IEEE, and basically including the timing information in the communications and being able to sync things up. You can contact us offline, and we'll be able to go in a lot more detail on that. I'm not sure I answered that one.
Well, that's all right, John. We'll get you the contact information for that after the show is over. So that's all the time that we have for questions for today. I'd like to thank John for a great presentation and a great Q&A session. And for more information related to today's webinar, please visit any of the resources links open before you. Within the next 24 to 48 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Additionally, you can view today's event on demand by visiting www.techonline.com. Once again, we'd like to thank you for attending today's webinar, Automotive Ethernet Moving to Time-Sensitive Environments, brought to you by Synopsys, Tech Online, and broadcast by UBM. This webinar is copyright 2015 by UBM. The presentation materials are owned by or copyrighted, if that is the case, by Synopsys and Tech Online, who are solely responsible for its content. The individual speaker is solely responsible for his content and opinions. On behalf of our guest, John Swanson, and Synopsys, I'm Chris Keach. We'd like to thank you for joining us, and we hope you have a great day.